Well, good evening, or whatever time of the day it is for you. You're here for the best part of your day, whatever time it is anyway, and that is the time of the day where you're going to get an answer to one of these strange and sometimes complicated LeetCode problems, in this case number 62, unique paths, which asks or says, a robot is located at the top left corner of an m by n grid, marked start in the diagram below. The robot can only move either down or right at any point in time. The robot is trying to reach the bottom right-hand corner of the grid, marked finish in the diagram below. How many possible unique paths are there? So you have to go from here all the way to here, and you could only go right or down. And so you could go right and down and then do this and then go all the way there, or you could go kind of one direction here and then go down. Either way, you could only go right or down. So it says for this, there's 28 ways of getting from start to finish. And we're not going to look at the other examples. And the reason is, well, here they actually give the same example as the top, just with no diagram. There's no other diagram. So this is yet another dynamic programming question. And let's go about solving it. Well, what do we see? We see that, for example, if we're going from here all the way to the finish, there's only one way because you can't go right anymore. There's nothing left. Similarly here, you can't go down anymore. You can only go right, and there's only one way of getting here. And if you were here, well, you would take the sum of this plus that, which is the path that you take, the path that you take going right plus the path that you take going down. And at this point, there's only one way on each. And at this point, there would be two ways starting from this square. Whenever you get to this square, there would be two ways. So we see that if we store the number of ways gradually, we could always get the sum of right plus down. And that's what we intend to do, starting with setting this finish at 1, and then this one will be the sum of everything going down because it can't go right. This one will be the sum of everything going right because it can't go down. And this one will have the choice of 2, and subsequently all the other squares except those at a edge position will have 2 choices. So we'll see how to solve this. First, a little sanity check. If m equals 0, or, and you could actually write or and then use C++, n equals 0. So let's do that just for the fun of it. Return 0. Now, we're going to come up with this matrix, which we're going to simulate, which is where we're going to store everything. So it'll be a vector of vectors of an int vector. So it's going to contain an int vector, and we'll call it my matrix. And we'll initialize it at size m, and each m is going to contain a vector int, pretty cool initialization, of size n, and we'll initialize the values at 0 over here. Pretty cool. So now we're going to tackle this little finish box over here. We're going to say my matrix, let's see now, m minus 1, and my matrix and n minus 1 equals 1. There's one way of getting to this box from itself. And eventually, after we fill everything out, we want to return the value here, which is the value at my matrix 0, 0. So also pretty cool. We don't need to come up with a new variable or anything. Okay, so now we have to iterate through the matrix. We're going to go kind of like this, and then at each, and then like that, and then like that. So how do we do that? Well, we'll come up with an int x equals, let's see now, it starts off at m minus 1. X has to be bigger or equal to 0, and x is going down. And then we have a, well, actually, let's call this, I like I and j for whatever reason. And actually, I don't know why. Sometimes I take x and y. Int j equals n minus 1. And j also has to be bigger or equal to 0, and then j is also going down. Or in this case, left. So we say, okay, so now what do we want to get for these values every time we see them? So first of all, we want to set the values of my matrix I and my matrix J equals. Now, oh, okay, well, let's set this here. So if I plus 1, if it's still smaller than m, that means we could take the stuff that's lower. Then my matrix I plus j plus equals my matrix I plus 1 j. And likewise, if j plus 1 is smaller than n, so that means that means the value doesn't hit an edge over here to the right. We didn't go overboard. Then we do the same kind of thing. We take this over here, and instead of I plus 1, we're going right, so it's j plus 1. So let's see if that worked. And I think that's it, actually. Let's see if that worked. Okay, so we see that it worked over here, and if we do submit, we have a winner. Okay, so I'm not necessarily concerned with memory usage here, and maybe we'll have to check why other people did better on that front. And that's it. Thanks a lot.